Hello, my name is Abigail Sykes, and I'm a PhD student in the Machado Lab at North Carolina State University. My research currently involves investigating the impact of on-farm biosecurity on the spread of infectious swine diseases. In this video, I'm going to guide you through our new specialized machine learning toolbox for biosecurity research, MrIML Biosecurity. MrIML is a package developed by Dr. Nick Fountain-Jones of the University of Tasmania and Dr. Gustavo Machado of North Carolina State University to facilitate the development of multivariate machine learning algorithms for use in a multitude of research areas, including infectious disease, ecology, and genetics. To improve the applicability of our biosecurity-based methodology, we extended this package to include functionalities specific for biosecurity research, which include predicted risk benchmarking and local importance functions. We will discuss these functions in the next few minutes. However, information and vignettes about all of the functions included in MrIML can be found at this URL. To find our specialized biosecurity vignette, we go to the MrIML web page and find our article menu. Here we can choose the swine biosecurity working example. While this vignette is extensive, we will only focus on the MrIML functionalities used. However, if you would like to know more about the methodology, please feel free to watch our overview of the methodology video. Turning our attention back to the vignette. After we have loaded up the packages and data needed, and we have processed and specified our model, we can then train and test our model. This is achieved through the MrIML predicts function, where we can specify whether we want to balance our data, run regression or classification models, specify the data and model to be used, whether we want to run the model in parallel on a server, and we can also specify a seed to avoid variation in the results if the function is run more than once. MrIML predicts produces a list object y-hats, which contains a lot of data regarding our model. Included in this data are the relationships and patterns identified by the model, and the positive predicted values for each farm, which will become our predicted outbreak risk. To determine the performance of a model, we can employ the MrIML performance function, which produces values for accuracy, sensitivity, specificity, and the Matthews correlation coefficient, or R-squared, depending on whether the model is for classification or regression, respectively. These metrics can be applied to help us choose the best performing or most appropriate model. Turning to interpretation, we have 5 functions demonstrated within the vignette, which can aid us in better understanding the patterns and relationships identified by the model. Firstly, using MrVIP and plotVI biosecurity, we can calculate and plot the overall importance of the variables on the model predictions. These results can be very useful to identify specific variables which may have a large impact on outbreak risk. However, to explore this overall importance further, we must look at the partial dependence. To achieve this, we can use the MrFlashlight function, which uses functionalities from the Flashlight package to calculate the partial dependence profiles between specific variables and overall model prediction. The results produced can be plotted as a line graph and allow us to observe how the dependence or importance between a variable and model prediction changes over different observed values. This can indicate which values of the variable are more likely to increase outbreak risk. We can then move on to benchmarking our predicted risk, which involves only one function, MrBenchmark. Through this function, we can determine whether we want to benchmark among systems or among farms within a single system using the type argument. This function also uses the data to calculate risk thresholds to better represent the risk level of farms. Finally, we can benchmark the local importance using MrLocalExplainer to produce both aggregated and individual visualizations. The aggregated visualization will be produced automatically from the function, while the individual visualization will be produced as a list object, allowing for the user to call specific individual plots. If you would like to find out more about MrIML and our research, please feel free to explore the rest of the MrIML site or visit the Machado Lab website. Thank you very much.